Hi there everybody, today we're going to look at distance time graphs. So distance time graphs are a way of basically representing what's gone on in terms of normally someone's travel. So how far away you've gone from a starting point and potentially returned it. So distance will go on the y-axis on the left hand side, and also you would expect time tends to go on the x-axis, which is the bottom. And then we would obviously try and interpret what is going on. All right, so here is a distance time graph of something that's happened. And I guess before we kind of answer any questions, let's have a think about what's happened. So someone's kind of set off, gone around about 4 kilometers away, stopped for a period of time, and then set off extremely quickly to go somewhere else, around about 5 kilometers away, because he's gone from 4 to 9, then stopped, and then he's hot-footed it back home. All right, so that seems to be the case. So maybe he's basically walked, stopped, ran, stopped, ran home. Okay, maybe. Okay, so A, moving away at a constant speed. All right, so it's a straight line, so constant speed. B is flat, so stationary. C, moving away at a constant speed, faster. D, stationary. And then E, moving back towards the start at a constant speed, again, straight line. So that's a kind of interpretation of it, and obviously try to put it into context, which, again, in reality, that's probably what you're going to get in an exam. So speed, which is a compound measure, which is in another lesson, but speed is calculated as distance over time. And because it's distance divided by time, actually the speed can be represented by the gradient. All right, so there is a lesson on gradient, but the gradient is often given as the change in y, that would be the distance, over the change in x, which would be the time. All right, so in this case, because of that, obviously the gradient of the line is actually the speed. Okay, the average speed, again, sometimes asked, that would be the total distance covered over the total time. All right, so we'll look at that one in a second, but what that actually means in terms of how you interpret it. But the average speed is the total distance over the total time. All right, so looking at the same graph, let's answer some questions on it. So find the speed of part A. Well, that would be the gradient, essentially, because it says in here, speed is the gradient of the line. So what he's gone is he's gone 4 kilometers in 1 hour, hasn't he? So change in y over change in x, so change in distance over change in time. So he's going to go 4 kilometers per hour. All right, so distance over time, 4 kilometers per hour. So arguably, I suppose you could say he walked. Okay, that seems a reasonable speed, 4 kilometers an hour, to be walking for that one. Find the average speed of the journey. Okay, so the average speed is the total distance. Well, he's gone 9 upwards and he's gone 9 back down. So he's travelled 18 overall, hasn't he, in terms of the total distance, because he went up to 9 and then he came back. So he's travelled 18 overall, and he's done that in 3 hours, hasn't he? So 18 kilometres in 3 hours. And yes, he's had a time where it's been 0, but because he's taken an average, we have to take this into consideration. So we've got 18 kilometres in 3 hours, so average speed is 6 kilometres per hour. Okay, I suppose I could ask you kind of question of the speed of C and the speed of E. I could ask you a bunch more questions, but I'm not gonna. We're gonna look at you drawing some. All right, so represent on a distance time graph. So a car travels 30 miles away from home in 2 hours. It's then parked for an hour and 30 minutes before travelling home at a constant speed of 10 miles an hour. All right, so what we've got is a graph with nothing on it, and we need to kind of put it in there. So if a car travels 30 miles away home in 2 hours, so in 2 hours, he travels 30 miles, so he's going to go from there to there. Okay, so plot that one. All right, so go from there to there, constant speed, it's going to take me 30 miles away. He's then going to park for an hour and 30 minutes, so I'm going to take my point and move along to 3:30. All right, so there you go. So there we go. And then the final bit, it says a constant speed of 10 miles per hour home. All right, so 10 miles per hour. So that means in 1 hour, it's going to take 10 miles to there. In another hour, it's going to 10 miles an hour to there. And then in another hour, it's going to go 10 miles an hour to there. So it's going to take him 3 hours to get home, because it's 30 miles and he does 10 miles per hour. So it's going to take me to there. All right, and that's my distance time graph. All right, relatively straightforward, I think. Obviously, you need to know about obviously speed, distance, time. So you haven't looked at lessons in terms of speed, distance, and time, that particular compound measure, then please do look at that one. Be very, very careful with the information that you are given. But please do visit maths-school.co.uk. There are obviously a bunch of questions on there for you to kind of practice and consolidate it at. And obviously, you're welcome to kind of revisit the video at any time. Thanks for listening.